Hello students, welcome to SAM classes. Today we're going to do physics PYQ section, electric charge and field. We'll be covering up each and every question from 2014 to 2020, and we'll be going in depth. What is the normal way to solve a problem? What is a shortcut method? Okay, if there are more than one methods, which method to adopt in exam, which is more highly you will remember it, okay, or the method which you will be able to think in a very fast manner and get the answer, or how you should change your thinking so that you are able to adapt to the time situation. Okay, so let's see and let's start the PYQ series. Now if you see the first question, student, okay, if a charge on a body is 1 nanocoulomb, so what they've given? Charge. So you can write Q is given, okay, so we don't have to 1 nanocoulomb. Now you should know what is 1 nanocoulomb stands for, okay, it's 10 power minus 9 coulomb, okay. Now how many electrons are there present in the body? So this question is like based on the fact of quantization of charge. We already know Q is equal to what? Any. The total number of charge on any body is the integral multiple of the charge on single electron. So E is equal to what, student? Oh, we need to find N. N is equal to what? Q by E. So how will we find? N is equal to, no, we don't have to do the total calculation behind it. Okay, we can, if you do a bit little of the calculation, we can eliminate most of the options and we can get the answer in just less than 5 seconds. Okay, so let's see what we have. Q is equal to 1 into 10 power minus 9 given, and charge on electron is 1.6 into 10 power minus 19. So the moment you send it up, what you'll get? 1 by 1.6 into 10 power 10. So if you see just the power only, all other powers is 10 power 19, 10 power 27, 10 power 28. So directly you can eliminate this. This is the correct answer. If you want to solve, let's say 10 by 16, okay, into 10 power 10. So what do you do? 5 by 8. Now if you solve it, you will get 0.625 into 10 power 10. And if you solve it furthermore, 6.25 into 10 power 9. So you could have got the answer without doing much all this. Okay, because see, in exam time we have very less of time, and if you want to do in less than 5 seconds, or if you want to do mentally also without writing this much, just to show you all, I wrote it. You can do it mentally also if somebody is able to figure out, okay, the power on the top is 10 power minus 9 and the bottom is 10 power minus 19. If I just take it up, I'll get 10 power something around 10. So which is the nearest power which we have in the answer? 10 power 9. So that is pretty decent, pretty simple, okay? You don't have to do anything else in that, okay? So that sums up. We should know that Q is equal to any quantization of charge, that the total charge contained in a body is always an integral number of the charge contained in single electron, okay? So, and we know the charge of electron is what? 1.6 into 10 power minus 19 coulomb charge, okay? So done, that's it. And you should know 1 nanocoulomb is what? Nano means 10 power minus 9. Correct. So nano means 10 power minus 9. So few basic things, if you know, you could have solved this question in less than 5 seconds, students. Okay. So very important for you all to solve the questions in less than 5 seconds. If you're able to maintain that, you'll be able to have a lot of time in physics for a few questions which are a bit deliberately like long, and you'll be able to have that time which you are fetching from these all simple questions. Okay. Let's see the next question. The second question is telling student two equal and opposite charges of same masses, okay, the two equal and opposite charges of masses m1 and m2, okay, they're accelerated in a uniform electric field through a same distance. Now what we need to know here is that there's the most important fact is whenever a charge is there and it is going through an electric field, and that electric field is, let's say, same. This electric field is E. One charge is Q, the other charge is minus Q. Force on a, what do you say, charge in an electric field is what, student? F is equal to QE. If you know this much, then what will happen? The force on the first charge, F1, is also equal to QE, and the force on the second one will be, since the other charge is negative of it, minus QE, but the magnitude of the force, student, is same, correct? If you see both, the magnitude value is what? QE and QE? Yeah. Now the direction is a different, correct? Because we have a minus sign for the negative one. So we'll take apart that we are not concerned much with the direction as of now. So both the forces are same. So can I say that force is equal to what? Mass into acceleration. So m1a1 is equal to what? m2a2. Both the forces are same. So m1 by m2 is equal to what? a1 a2 by a1. Correct. Now what they have asked is what is a1 by a2. Okay. So m1 by m2 we already know it's half, and that is equal to a2 by a1. So what is a1 by 2? Just reciprocate it. So it is 2. Okay. So what will be the answer? a1 by a2. a1 by a2 answer will be 2, student. Okay. So the value a1 by a2 already given in the first option is 2. Okay. So very simple question. What we need to know here is whenever something is in a uniform electric field, so E is same throughout. Understand, E is electric field is same throughout. Now two charges are there. One is Q and the other is minus Q. Two charges are there. One is Q, the other is minus Q. So force on each charge is equal to what? QE, charge into electric field. So that value of the force is same, though the direction in the second case scenario is different, but the magnitude of the force contained by both of the charges is same. So once the magnitude of the force is same, we can use the formula. Force is equal to what? Mass into acceleration. So mass of the first charge into acceleration of that charge is equal to mass of the second charge into acceleration of that charge. And by simply directly, we can get the answer. Nothing much. This also you can solve in less than 5 seconds. Okay. Once you know this concept, what is the most important concept here? That whenever a charge is kept in a uniform electric field, what happens? The force on it is what? Same, student. Okay. The magnitude of the force is same. Okay. Now let's see the next question. Now let's see the next question that we have here. The angle between the dipole moment and the electric field at any point on the equatorial plane is. Now we have to find the angle between what? Dipole moment, we know P, and electric field. Now for what point? For an equatorial plane. Now first thing we need to understand what is an equatorial plane. So let's see, we have a dipole. So one positive charge, or make it like one negative charge, one positive charge, separated by a small distance. Okay. Now we will draw a perpendicular bisector on this, correct? So the moment we draw a perpendicular bisector, this point or this line becomes the equatorial plane. Now we already know that this charge, if you see here, this charge will try to bring it this side, and this charge will, the positive one, will push that whatever the positive here is at this point for the electric field like this. So the net electric field we have already done, students, okay, in the concept video. So you know the net electric field is like this, correct? So, and we already know that, what do you say, the dipole, the direction of the dipole is what? From the negative to the positive. The direction of the dipole is from negative to the positive. So this is the direction of P, this is the direction of electric field. So what is the direction between them is? Theta is equal to 180 degree. Theta is equal to, pretty simple, 180 degree. So from the equatorial plane and from the dipole part, two questions are pretty common in KCET. Okay, one is the angle between E and P. So E and P, they are opposite to each other, or they are opposite to each other. First is this, okay, and what is the value or relation between E axial and E equatorial? So these two things are very much important along with the formula. So do work it out, do understand. Okay, if any doubt, put it on the comment section. Let's see the next question. The next question, what they're telling is the electric field lines form closed loop. See, if we read the first line only, okay, so electric field lines form closed loop. What do you mean by that? So let's say we have a positive charge here, negative here. So is the electric field line, they originate from the where? So they originate from the positive part and they end up in the negative part, correct? So what do you mean by self loop, student? Means it should originate and come back to the same thing. So does this happen? No, correct. They come out from the positive and go towards the ended in the negative part. So directly we can say, so this is not an option. So this one is the incorrect. So this is the answer, correct. So a lot of times what happens, student, they don't see this word incorrect, and they're in a very fast manner, they're in a very, what to say, hurry situation, and they directly overlook. So you should not overlook it, okay? You should read out the question. A lot of times, a lot of students we have seen who has done mistakes without reading the proper questions just to do fast way. They have read, okay, which of the following statement is correct? Okay, incorrect, they have skipped. You should not do it like that, okay? Clear? Let's see the next question. So here what is happening here is two spheres of charges plus 6 coulomb and plus 9 coulomb. So we have plus 6 microcoulomb and plus 9 microcoulomb we have charges, okay? They're separated by a distance, let's say d. This is the basic thing. So two charges are there, force will be there, coulomb force. So F is equal to what? K, Q1, Q2 by R square. So 54, okay, microcoulomb by d square, correct. That's it. Now what else we have? When a charge of minus 3 is given to both of the sphere and kept at the same distance as before, the new force of repulsion. Now what you're doing is you're adding a charge of minus 3 to both of them. The moment we add a charge of minus 3, okay, to both of them, what will happen? So the moment, let's say I'm adding minus 3 here. So this will become plus 3 microcoulomb and this will become, what do you say? How much? Plus 6 microcoulomb. So if you see, there is a net reduction in the total charge. So this F dash will be nothing but F into what? 18 microcoulomb by, because you have kept the d square same, correct? So if you see the difference between these two, directly you don't have to solve it. The difference between these two, if you see, it is what? 3 times, okay, less than that, correct? So directly you can mark the option F by 3. Now, do I need to write down and do everything? No. Even if I write the value 96 or 54 for the charge and for the next charge 18, okay, because I already know d square is same for both the case, directly I can do that the next force is 1/3 of it, okay, or 18 by 54, I will directly get 1/3 of it. Okay, so I don't have to write everything and you can just do it by 1 second, okay? So what you can do, the new charges you should know, the moment you are adding up minus 3 and minus 3 to both, you are getting 18 of the product because d you have kept same. So now force will be what? Directly proportional to Q1, Q2 because K and D you have made it same. So here the F1 force or the final force is equal to proportional to 18. Okay, but since the unit is same for both of them, initial and after, so we don't have to worry. And the original force was directly proportional to what? 9 6 are 54. So directly if you want to find the relation, it will be what? 1/3, correct? So you don't have to do everything. It can be solved within 2 to 3 seconds only. Okay. Now, a very good question they have asked, if there is only one type of charge in the universe, let's say suddenly our universe has only one kind of charge, may it be positive, may it be negative, may it be none, may it be something else, okay? Now, in that case scenario, a lot of students, what they do, they start imagining, okay, now we just have one charge, what will I take? Positive I'll take, negative I'll take, what else, a new charge or anything else, okay? So they don't read the whole question. So in that case scenario, 4 options they have given. Okay. If you see all these 4 options, E dot ds will remind you of Gauss law. Correct. E dot ds will always remind you of what? E dot delta s will always remind you of Gauss law. What did Gauss law said? That surface integral of E dot ds is what? Charge enclosed by epsilon naught. So what he said? Charge enclosed. Did he say what kind of charge enclosed? No. He didn't say. He said positive charge, negative charge. He said total charge enclosed by epsilon naught. So what is the charge enclosed? Whatever it is. Okay. So if you see, E dot ds is equal to 0 if the charge is outside. So if for any Gaussian surface, if some charge is inside, let's say Q charge is there. So integration of E dot ds will be what? Q by epsilon naught. If some charge is already outside, it's not in the inside the what do you say Gaussian surface. If it is outside here, so the charge enclosed is what? 0. So Q is 0. If Q is 0, then integral of E dot ds will be how much? 0. That's it. So there is nothing to be worried about what kind of charge it is. Okay. So there is nothing about that. So let's see all the options. E dot ds is not equal to 0 on any surface. Again wrong. E dot ds could not be defined. Why it should not be defined? Because Gauss sir hasn't given anything about what kind of charge we are talking. We are talking about the total charge. whatever it is, okay, negative, positive, sometimes, let's say somebody brought something else or something, illa, doesn't matter, okay. Now, E dot ds is infinity if the charge is inside. Why will it be infinity? Because epsilon naught is a constant. This, why will it change? It is directly proportional. Okay. You're not making the charge infinite or something. So you're just changing that the charge is of one nature, maybe positive or one type. Okay. Now, so the fourth option, E dot ds is zero if the charge is outside. If outside, the net charge inside is what? Zero. Or charge enclosed. Enclosed means what? Within this part of the Gaussian surface, what is the charge? So if you see distance, all the charge is outside, so no charge is inside. So what will happen? The by Gauss law, charge enclosed will be what? Zero. So it will be zero. Now the moment you say charge enclosed is Q, so it will be Q by epsilon naught. That's it. Let's see the next question. What they have given the next question is an electron of mass m, charge E, falls through a distance k meter in a uniform electric field, then the time of the fall. Okay. Now they want to know what is the time of the fall. Okay. And the electron here, I think so, it will be H. Okay. Okay. A bit, what is the typing issues here, student? Okay. Don't worry. Now, so basically they have made a field like this. So let's make it negative. What do you say? Negative here, falling since. And let's make it positive. And an electron, let's say here, it's falling down. Correct. So when an electron is falling down, what will happen? It is falling under a force. So F is equal to QE, that we know. Okay. So F is equal to charge into electric field. Now in this case, what is the charge, student? Simple. Electron has charge what? E. So small e into capital E. So this part is clear. Now we know acceleration. Everybody knows acceleration is what? Force by mass. So that is equal to E by M. Now this concept, student, will be used in a lot of questions. So do understand this concept. Whenever our electron is there in a electric field, the force on that is QE, and that is equal to, in case of electron, the charge on electron, that is E small e, into the electric field, that is capital E. Now acceleration, directly straight formula, force by mass. So force by mass of electron, that is E by M. We got it here. Now initially when it started, it has zero velocity. Okay. And finally, let's say it is covering a height H. So that is equal to S. So now we remember the equations of accelerated motion. S is equal to ut plus half at square. Correct. You all remember this, all we did in class 9th. Correct. So S is nothing but H, height, what it covered, or the distance it fell. Initial velocity was 0, so ut is gone. Plus half into A is what? E by M into t square. Now what you can do, send this, what you say, m and 2m, that's it, to 2hm by EE is equal to what? T square. So T will be equal to what? Root under of 2hm by E into capital E. That's it. So the question, though it looked a lot difficult, nothing it had, okay. And if you do it very fast also, it will take less than 5 seconds, students, okay. So physics is not at all that difficult, okay. If you understand, if you're able to, what do you say, break down the concepts in smaller parts, you can easily solve it, okay. Now let's see the next question. So this question I already told you, this is very similar, and a lot of concepts on this is what you say, already taken in each year. Something or the other comes from this. So whenever we have a dipole, okay, so let's say minus q plus q, okay. So we have a dipole like this, length is 12. Now if we are finding electric field, anything on the line joining the charge, what is action? Action, student, is nothing but, what do you say, anything lying on line joining the charges. So if we have anything on the line joining the charges, that is action. And we already know the net, what do you say, electric field in this scenario is what? Anybody come on? So this negative is pulling it this side, correct? We already know, we have done. And this positive is pushing it that side. But this positive is more strong. Why? Because the distance is less. F is equal to what? Electric field is inversely proportional to what? D square, correct. So this is dominating. So E net is along this side. Now just now we did a question on E equatorial where we saw that this was the direction of the for the equatorial point. What is equatorial? If we make a perpendicular bisector, anything lying on the plane of the perpendicular bisector is equatorial. Okay, so E net is this side, correct? So the direction or the what do you say? Both are of opposite sign, correct? If one is on the one side, the other is on the other side. So angle between them is 180 degree. So, and we already know by the formula, the magnitude difference between these two is what? Double of it, correct? So we already know that. So if we do that, then what you'll get? E axial will be equal to minus 2 times of E equatorial. That's it. Done. Both in vector form. So the option C is correct. That's it. Nothing was there. Was it that difficult, student? Okay. So if you remember what is there for the dipole moment, for the equatorial and axial, and what you have to remember for the KCT part, the direction part. Okay. And along with the direction, this part also. So the, what do you say? The direction of the dipole moment P. For the axial, it is along the axial part, and for the equatorial, it is making an angle of 180 degree. Clear, huh? Okay. So few points which you should know is the angle between P and E equatorial is 180. The angle between P and E axial is 0 degree. Okay. So these two things you should know, and then this thing you should know. Okay. If you know these two things and this thing, you'll be able to solve most of the question. Okay. Now let's see this question. Two spheres of electric charge plus 2 nanocoulomb and minus 8 nanocoulomb. So we have plus 2 nanocoulomb here and minus 8 nanocoulomb here. They're separated at a distance of d. Now, if they're allowed to touch each other. Now, first let's see the first case scenario. So since they're separated, they'll have Coulomb's law. What will be the force of attraction? K, Q1, Q2. So 16 by d square. Okay. Not going with the plus minus and all. Okay, we don't need that much. So this is the basic. Now what is the second thing what it is telling? Now second thing what they're telling is if they're allowed to touch each other. So what will happen? The moment these two charges they touch each other by a wire or anything, the charges will transfer from the higher to the lower. So what will be the total charges available? Minus 8 plus 2. So that is equal to minus 6. And that will be divided among 2. So that will be minus 3. So each one will be having minus 3 charge. So now what will be the force, student? So it will be 9k by d square. Okay, F dash will be 9k by d square. Now they're asking is what is the new distance between them to get a repulsive force of same magnitude. Now they don't want the force to differ. They want the same magnitude force. So in that case scenario, if you want the same magnitude force, your distance has to change. Correct. Now first understand your earlier force was 16. Now the value reduced it to 9. So what do you have to do? You have to reduce this distance so that what will happen? This force value will increase. Correct. Because you want to make it same. So what we can do, we can make d1 and we can make d2. Correct. So if the values are same, we can write 16k d1 square is equal to what? 9k d2 square. Correct. So k gone. Okay. So d1 by d2 is equal to what? d2 by d1 is equal to 9 by 16. Correct. So if I send the d1 that side, so what you will get? This is whole square. So d2 by d1 is equal to 3 by 4. So you can understand from here, we don't have to solve the whole thing. So what we could have done is, first, the basic simple thing you should know that two charges are there, Coulomb's law will be applicable. The moment you touch them, okay, the moment they are in touch with each other, the charges will redistribute. How much? The total charge. So now what we can see is the moment it redistributes, it has minus 3 both. So we know the old force, we know the new one. Just since the forces are equal, they said, okay, they're of equal magnitude, just equate it. So you'll get d1 by d2. d2 by d1 is equal to 3 by 4, or d2 you will get as 3 by 4 d1. So which option matches? Third. Now you don't have to do all these kinds of calculations. What you can skip without writing directly, you could have written 16 by, because we know k is also same, 16 by d1 square, and that is equal to, for the second case scenario, you should calculate in mind, since we are touching each other, So what is the total charge available? Minus 6. Divide by 2 spheres. Okay. So how much? Minus 3 to each. Multiply them. Q1, Q2. So 9. So 9 by D2 square. That's it. The moment you solve, okay. So D1 square is equal to how much you will get? Or we need to find D2. So D2 square is equal to 9 by 16 of D1 square. That's it. So 3 by 4 D. So it will just take not more than 5 to 10 seconds, students. Okay. The questions in this chapter are pretty simple, pretty straightforward. Let's see the next question. So here, let's understand the question first. So what they have done is 4 into 10 power 10 electrons are removed from a neutral. So a neutral body has what charge? 0. Negative or equal to positive, so no charge. The moment you are removing what you say this much of electrons, so basically what you are doing, you are giving it positively charged because you are removing the negative. So what will be extra? Positive. So you need to understand that how much positive, how much negative you removed. Correct, because earlier it was neutral. The total amount of negative was equal to total amount of positive. Now since you have removed this much of electrons, so one electron has how many charge? Into 10 power minus 90. Done. Correct. Now you can see the numbers here, they don't contain any power. So even if I do the calculation without power, I'll get the exact answer. So let's see and let's try to do it in a very fast manner. Okay. So we got this much of charge it is. Okay. Now what they have said is of diameter 20. The sphere is of diameter 20. So radius how much, student? 10 centimeter. Don't worry about what you say meter and all conversion since power is not there. What you say? Everything is chill here. Okay. So now we have to find the magnitude of electric field at a distance of 20 centimeter. Just from here to here is 20 centimeter. So nothing is there. Directly E formula. What is E? K. K we already know. I'll write 9 into 10 power. I don't need to write the power also. So what do you say? K into Q square by, so 1.6 into 4 and divided by D square, correct? So what is my D, student? 2 square, so that is 4, like write it down 2 square, correct? So so this and this will be cancelled and 9 into 1.6 is how much? 144, correct? So you'll get the value 1440. So you don't have to do any calculation. See, this is worthless, this is worthless. I didn't need to convert this, okay. If you knew, like, you could have done in mind, electric field is equal to K value will 9 come. Okay, I already know that from the charge, how much I have? 4 into 1.6 and divided by radius square. So radius is how much? Or the distance is how much? 2. So 2 square is 4. So done. Just this much is 144 and rest all values are like pretty far apart. Okay, so we don't have to worry. See, it took how much? Not more than 1 second or max less than 5 seconds. So most of the questions, students, you can solve in less than 5 seconds. You don't have to worry about anything. A bit if you understand and make a practice of solving it like this, okay, you will be in a very good position. You have a lot of time saved. You can revise the other parts and you can dedicate that time for really longer questions, okay, where you can score, but there we don't have any other option except to solve them, okay. Let's see the next question. Now in the next question, student, what you can see, 3-point charges are there placed at the corners of a triangle, of an equilateral triangle. So very simple. Let's see. Make an equilateral triangle. So equilateral triangle, just remember all sides, all angles is what? 60 degree. So one charge here is, let's say I put minus 4q, plus 2q and plus 2q. The moment you see something like this, what you can see is this 4q, we can arrange it as minus 2q, minus 2q. The moment we do that, okay, so minus 2q this side, minus 2q this side, it will form a what? A dipole here. See, one dipole here. Okay, so we can now write it as one dipole P1 here. And what is the direction of the dipole, student? Negative to positive. Negative to positive. The dipole moment direction is negative to positive. So we have two vectors P1 and P2 like this, and the angle between them is 60 degree. Now this whole question became a vector question. Now you need to remember one formula. What was the formula? How to find the resultant of a two vector and the angle was given. What is the formula? Root under of a square plus b square plus 2ab cos theta. Correct. So here if I put r is equal to root under of p square, again one more p square plus 2p square, and cos is how much, student? The angle between them 60 degree. So if you remember the value cos 60 is how much? Half. So this and this gone. So what I got is root 3p. Now you already know what is dipole here. Dipole is equal to the distance between them is given as side is of x here, x. So p is equal to what? Charge into the distance between them. So what will be our answer? Root 3 into 2qx. Correct. So which answer? So 2 root 3qx. That's it. So is the question anywhere difficult anywhere? No. So you just need to understand only the first line. Okay. How you are breaking that minus 4q to minus 2q minus 2q. That is the most important part. Once you have already got, and you should know the direction, even if it was a different direction, it would have added only. Okay. Now, so already we had two dipoles. We knew the angle between them. You should remember the formula, how to find the resultant of two vectors when you know the angle between them. Okay. So that is the most important thing. If you remember this formula, you can solve it directly. So nothing is there in this question also. Okay. Max, it should take 10 seconds or max to max 15 seconds, students. Okay. An exam. Okay. Let's see the next question. So let's see this question. The magnitude of a point charge due to which the electric field 30 centimeter away has a magnitude this value. Okay. So what they have given us electric field. How much it is? 2 Newton per coulomb. That's it. Now what they have given the distance that is equal to 30 centimeter. Now they want us to know the charge. So what is the electric field formula? KQ by R square. Correct. So what, since if I see all the powers, this is like 10 power minus 11, all are same, so I'll just cancel it. So I just have to play with the numbers 2, 5, 3 and 9. Okay. So what I'll do, in place of K, I'll put, this electric field is 2. K I'll put as 9. I won't take the powers. And charge I don't know. I'll keep it like this. And the radius again it's 3. So I'll square it up. Okay. So it will be 9. So 9 and 9 gone. So Q is equal to what? 2. That's it. So was it anything difficult? Now if somebody wants, sir, we want to solve it. Okay. If you want to solve also same thing, no difference, nothing difference is here. Directly put the values, you'll get exactly the same thing, student. Okay. You'll get exactly the same thing. Let's see how to solve it with all the values and everything. If you want to solve. Okay. So Q, we already know E is equal to KQ by D square. Correct. So that is equal to, from here Q is equal to ED square by K. So electric field is 2, D square is 30, what do you say, 30 centimeters. So convert it, 30 divided by 100 into 100. Correct. Because it is 30 centimeters square, so 30 again. And divided by 9 into 10 power 9. Correct. So what we are getting, students? This 2, 1 gone, 1 gone. Okay. This gone, 2 gone, that's it. So how much we have left? This 3 and this 3 gone, this 9 is gone. So 2 into 10 power, how much we are getting? Minus 11. Correct, this is there. That's it. If you want, you can solve. Otherwise, you can just go directly with this. You'll get the answer in less than 2 seconds. Okay. Let's see the next question. So students, let's see this question. Okay, what we have here is the force of repulsion what they have given between two identical positive charge when kept with a separation of R is N. Okay, so what they have given, two charges are there, Q1 and Q2, kept at a distance between R. Now, and in air, the force between them F is equal to is F, and that is equal to what? K Q1 Q2 by R square. Pretty simple. Now, if you see next case scenario, what they've done, they brought a dielectric and inserted it here. They brought a dielectric, inserted it here, but they didn't insert for the whole thing. They did insert it for just half of the part. So if you see the thickness of the dielectric, T is equal to R by 2. So you need to understand they can insert for what is a half of it. They can insert for what is a 1/4 of it. They can insert for anything. So you need to understand what are the different things involved in this. So what is one? The moment we insert a dielectric and the dielectric constant is 4. Okay. So what is the formula to find the new force? That is equal to K Q square by R minus T. Okay. Plus T root K whole square. Okay. So this is the formula. So let's put it up. So F dash is equal to K Q square. Now we already know T is equal to R by 2. So R minus R by 2 is equal to what? Half only. Plus T is what? R by 2 into root K, root of 4, and then whole square. So that is equal to KQ square by, it will be R by 2, and this will be plus R whole square. Correct. So what we are getting, students? KQ square by, and if you see, this is 3R by 2 whole square. So if you send it upward, 4KQ square by 9R square. So we already know this value is nothing but F. So we got 4F by 9. What is the value we got? 4F by 9. It will take max 30 seconds, okay? Once you know this formula, whatever it comes up, you can put it up and solve it, okay? Now what is given in this question, student? A charge is given 2Q. It is divided at first into two equal parts, Q1 and Q2, okay? So let's say one charge is Q1 and the other charge is Q2, okay? Now later the charges are placed at a certain distance, let's say D, okay? If the force of attraction between the two charges is maximum, the moment we listen to the word maxima or minima, we remember that what we have to differentiate and find it out, correct? So in basically maths, in the chapter section AOD, application of derivatives, we do first derivative test, second derivative test, and we figure out what is the maxima and where it is like lying, okay, or what is the minimum. Now the basic simple method to find maxima or minima is to differentiate. First hand, when you differentiate, okay, you will get equal to 0, you will get the critical points. When you double differentiate, if you get less than 0, you have maxima. If you get, what do you say, more than 0, you have minimum. So we already know the conditions, okay. So first derivative, like dy by dx, if I am differentiating, is equal to 0, gives me what? Critical point, students, correct. Now the second derivative, d2y by dx square, at those critical points, okay, let's say C1. If it is less than 0, then it is maxima. And the double derivative, and the double derivative at that point is greater than 0, then it is minimum. No. So this much you know from the maths part of AOD, okay. So let's see how will we solve the question. So this charge 2q is equal to what? Q1 plus q2, because that's it. From this 2q charge we have divided and formed these two, okay. Next, what we know, force is equal to, what we can write is q2 is equal to 2q minus q1. See, my first target is to write the expression of force in terms of one charge, okay. So it will become easy for me to differentiate. So k q1 into 2q minus q1. Now this 2q, the total charge is constant, okay, and this r square is constant, this k is constant. So it becomes very easy. When I'm differentiating this function df by dq1, I have to get that is equal to what? 0. So by differentiating the function and getting 0, what do we get? We get the critical value, the values of q1, okay, for which the function can be maxima or minima, okay. So let's differentiate. Differentiation is fun. What do you say, guys? So we already know k and r square is constant. Just take it out, okay. So what we have here is 2q q1 minus q1 square, correct. So we have to differentiate this. So k by r square, we took it out. The moment we differentiated, 2q was constant again, and differentiation of dq1 by dq1 is what? 1. If I do dq1 by dq1, how much you will get? 1. Okay, I'm showing in detail so that you don't do any mistake, okay. And differentiation of this will be what? 2q1 only, correct. Any doubt? And that is equal to 0, correct. Now what I'll see, what I got is, I'll send it to that side because this is constant anyway, I can cut. So what I got, 2q is equal to 2q1. So what I got, q by q1 is equal to 1. That's it. So pretty simple, okay. So you don't have to write all this stuff. The moment you already can do this much in your brain, mental, you write one step like here, differentiate, the next step you have the answer, okay. So you don't have to do all so much of stuff. Very simple, 2 to 3 steps max. It will take less than like what, 15 seconds or 20 seconds, okay. Now a lot of students say, sir, what about a logical way of solving this question? Now whenever we had in maths, in AOD, whenever we had a number like 20, we had to divide it into two parts such that it becomes maximum, the product. So mostly we got the answer as half and half, correct. So by that logic also, if you go, this 2q charge, if you divide, it will be what? Q and Q. Okay. So by that logic, if you go, it will be what? In the form of Q by Q, correct? Half half. Okay. So if you go by that logic, you will get the answer as one is Q, the other is also Q. Okay. So that logic also, we have seen a lot of questions. Okay. In your what you say NCERT and other good books, you will be seeing that. Okay. Now coming to the next part. Let's see the next question, student. In the next question, student, what they have given is, they have given us an electric dipole is kept in a non-uniform electric field. So first thing what you should know is, this is, let's say, a non-uniform electric field. Okay. Means what you say electric field is changing at different places. Non-uniform means this much we all know. Correct. So let's say you're placing a dipole. So here charge is Q, here also charge is minus Q. But since electric field here is E1, electric field here is E2. Okay. So the force here, let's say, is in this direction, let's say. So F is equal to, or F1 is equal to Q E1. Okay. Let's, for the time's sake, understand that this force is greater. Okay. This is greater. E1 is greater than E2. Okay. Among these two, since they are non-uniform, anyone might be greater. Okay. Either E1 or E2. So we are taking that E1 is greater. So this force will be more bigger, and this force F2, which is equal to minus of QE2, is smaller. So what will happen is, first it will rotate, student, correct? The torque will be there. But along with the torque, since both the force are not same, so they will have a translation. They'll move also. So what they'll do, they'll rotate also, okay, and they'll move also, okay. So it will be like rotate plus move, correct? So due to the torque, they will rotate, and due to the net force, okay, F net is there also, because F net is not able to get cancelled, they will move also, okay, whichever direction. So they will rotate and move. So it will rotate like this and move, okay. So next time it will rotate and move, okay. So it is doing what? Moving and rotating, moving and rotating. So here, what you say, a force and a torque, both will be there, okay. Let's see the next question. Now, a very good question we have got here. They have given us a cube. Okay, so let's bring it out, this one. Okay. Oh, we can't bring it out. So we can take a screenshot here. So we'll just copy it. And see here, if you put up this. Now, so in this case, what they're trying to say is, student, okay, they have put up a charge here. Okay, they have put up a charge here at one of the corners, and they're telling us, or they're asking us, what is the electric flux through the phase? Which one? This phase, A, B, C, D. Okay. Now in flux, you remember flux is equal to what? E dot ds. Correct. E vector dot ds vector. Now how is the electric field coming from this charge? Is like this. Correct. For this part like this. Correct. Correct. So if you see, the electric field is parallel to, so we can say electric field is parallel to this ABCD plane, correct? Now if you can understand this much, means electric field is like parallel to this plane. Now what will be the area vector? I told you, student, ds vector is nothing but always outward normal. Outward normal, okay? ds vector is nothing but always outward normal. So if you see, the outward normal will be like this. This will be our ds vector, and this is our electric field. Now if you see, the angle between these two is what? 90 degree. So E ds cos 90, how much? So cos 90 is how much? 0. So 0. So flux through that is 0. Now a lot of students, sir, what if this contribution to this is what? 1/8 of it, it is be able to join. Yeah, that is correct, the contribution. But see, the angle between E and the area vector is 90 degree. Whatever, how much it is contributing, that is there. But if the electric field and the area vector are perpendicular to each other, the flux through them will be what? 0. Directly we can do. Okay. Let's see the next one. The next one, what they have said is, the electric field lines, okay, on the left have twice the separation of those on the right. So by telling this, what they mean, the electric field line here, they're saying a comparison, and here that it is more here and it is less here. By how much? Half the value. Okay. So what they're trying to say is, the electric field at A point is equal to what? 40 V by M. Now we already know we have a relation of electric field in the PU. Okay, what is that relation? E is equal to V by M. Correct. Potential gradient. Okay, we have done a lot of what do you say theory derivation on that. Correct. So EA is equal to electric field at A is equal to what? 40 V by M. Now, so EB, electric field at point B will be what, student? Half of that, because they're saying that whatever the field lines here, okay, they have half less field lines here, okay. So what you can say, 20 V by M, correct. So the moment we get this, now force at B point is equal to what? Electric field at B into charge F is equal to what? QE, that's simple. So that is equal to 20 into 20. So we don't have to see for what they say the values here, because we have only one value of 4. So whatever the powers will be equal to, what we say, we can directly neglect and directly solve like this. Okay, we don't have to put everything. Now that's it done. Now let's see the next part of this question. Let's see the next question. Now student, let's see the question what they have given here. An infinitely long thin straight wire has a uniform charge density. So they gave you lambda first. Then they've asked what is the magnitude of electric field. See, they have made like directly a formula based question. So basically they want to know that you remember the formula due to a infinitely thin straight wire. What is that formula? E is equal to lambda by 2 pi r epsilon naught. Correct. Now you'll see lambda is there, sir. Epsilon naught value we know. 2 pi r all value we know. So what happens here? They wanted to check your, what do you say, ability to turn the values in such a way so that you can make the calculation simple. So what I'm going to do is I'll multiply two top and bottom. They'll say, sir, what is the reason for multiplying top and bottom? So pretty simple. We already know the value of 4 pi epsilon naught. Correct, friend? So we'll use that one. Okay. So we know 2 lambda and this 4 pi epsilon naught is how much? 1 by 4 pi epsilon naught. That is the value of what? K, no. So that is equal to what? 9 into 10 power 9. Correct. So 9 into 10 power 9. Even if I don't do with the power, it's okay. Because most all the powers are what? 10 power 8, 10 power 8, 10 power 8, 10 power 8. So forget about the powers. Who cares about the powers? Correct. So what do you do? 2 lambda into 9 by r is how much? 2 only. Correct. So 2 gone. So lambda is what? 1 by 4. So 9 by 4. So 9 by 4 is how much? 2.25 student. So something with 2.25, come on. C option. That's it. So pretty simple. Here what they wanted you to know. First thing they wanted you to know that what is the formula for a uniform infinitely long straight wire. The moment if you know the electric field formula for a uniformly what do you say long straight wire, okay, you'll be able to use this formula. Once you know the formula, they don't want you to what do you say waste the whole time. If you want to solve in less than like 10 seconds, they want you to understand that you can use 4 pi epsilon naught by multiplying two top and bottom. The moment you're using this, they gave you what? All the power same. Okay. They gave you all the power same. So you don't have to put these all powers. Okay. Directly, you can put up the main values and you can get an answer. See, none of the values are like 2.25 into something. So you don't have to worry also. Okay. Let's see the next question. Now, in this question, a bit you have to understand. It's a good question, student. A dipole of dipole moment P and moment of inertia I is placed in a uniform electric field. So what you have done, you have placed a dipole, okay, having dipole moment P and moment of inertia I, okay, in a uniform electric field. If it is displaced slightly, okay, so what they're trying to say, this is like a uniform electric field and you placed a dipole here. After placing a dipole, okay, you displaced it slightly. Now they're telling that the moment you displace, it is trying to oscillate, okay? It is trying to oscillate. In that case, what is the time period? Now see, basically for this, we don't have the formula in the NCERT part. So what we remember, in magnetism, we have a part. And what was the formula? T is equal to 2 pi under root I by mb, correct? Having moment of inertia. And now if you recollect, student, M was what? Magnetic moment. So in this case for the dipole, it will be dipole moment. M is similar to B, P, and B was what? Magnetic field. So here in case for the electric part, it will be electric field. So directly if you apply that formula, T is equal to 2 pi under root I by what? P. That's it. So what is that option? That's it, B option, correct? Okay. Now students, we are working dedicatedly and very hard to bring up the rest upcoming, whatever the videos are left and whatever the course we have to complete. So do help us, do like, share and subscribe, do comment, okay, because your comments are very important. We get to know whether how much dedication we have put is more or less, and whether the videos are useful to you in whatever ways, and if we can make it more better for you all students, okay, in whichever way. So do put that one, okay. We'll take your reviews honestly and we'll work on that. Okay, so thank you and best of luck.